Hey everyone, welcome back to yet another episode of GenAI Vlog. So this couple of episodes, we've been focusing on Gradio application. Gradio is an open source Python package that allows you to quickly build your demo web-based application to showcase your machine learning model, AI model, large language model, or it can just be any arbitrary Python functions if you want, right? It can allow you to share a link with your stakeholder to prove out the concept in just a few seconds. So, with that all being said, today we're going to be focusing on speech-to-speech model, right? So let's go to our notebook. First things first, let's start with the system diagram. So here I have a couple of mermaid code to spell out the system diagram for how it works. And then specifically here, what I'm going to do is I am going to use the one with Anthropic Claude. So let me open this link and let me walk you guys through what's going on. So this is called a sequence diagram. A sequence diagram typically go from left to right and then will also come back. It's one of my favorite way to explain how the system works. And sometimes I will even just jump right in a sequence diagram without a system diagram. So with all that being said, let's jump right into the sequence diagram. So start with the browser, right? Start with the browser. Users on the browser, right? User is on the browser. It's a speech model, so there's no typing. You're talking to it, right? So record some sort of voice using microphone. Obviously, assume that you have a microphone, right? And then a Gradio interface will collect that data. So whatever the data is, it's an audio format, right? It's a WAV file, WebM file, you get the idea. So it will save that file. Obviously has a path. It's a temporary path because we don't have a database or something like that, right? We're not developing this on the cloud. We're developing this in a very basic, simple container. So it's a safe space, right? The data is there. Once you kill the app, then the data is gone, right? So it's a temp file in that application container, and then the voice processor is going to convert the audio to a wave format. And then the speech recognition API is going to transcribe the audio to text. So once the speech recognition model returns back the text, you can then consider now becomes a text-to-text model, right? Because the speech portion is already being processed. So here, there is a condition, right? The condition, which is in this dashed box, right? This alt, this means alternative. In the mermaid language, on a sequence diagram, this means an if statement. So if the transcription is successful, meaning that it's not like music or something, right? It is indeed someone saying something in natural language. So if the transcription is successful, you get the text, and then the text can then be sent to a Anthropic Claude API. And then you can call a model, right? Whatever model you want, right? In this case, I use Sonnet 4. It's a very recent model, right? It's released 2025 in May 14th. So it's a very recent model. You can set up whatever token, whatever temperature, and then you're going to get some response back. So this arrow is going to send the text into Anthropic API. So once you get that text back, it's going to return a text, right? Once you return that text, you can then probably voice it if you want to. So the way to do that is called text to speech. And once you voice it, you can then play out loud, right? Once you play out loud, you can then return the MP3 file and then return that into your radio interface. And then your radio interface can then play the audio. So this is assuming that the transcription is successful. However, it is also possible that this transcription failed, right? Maybe it's a junk, maybe your microphone didn't work, maybe you're singing a song, right? It's not really words, right? Maybe you're just humming something, or maybe it's a music. So in all those scenarios, this transcription will fail. And then if that's the case, you're just gonna be getting an error message, and then it will be an error audio, right? There's no words, right? So that means there's no inference from the large language model, right? All that stuff no longer work anymore. So that's the other scenario. Then obviously, we're talking about user interface, so we need to take that into consideration. So let's zoom back out on a high level. That's how it looked like. It looks crazy, it looks scary, but once I show you the app, it should look fairly simple. So here it's how the app look like on the left-hand side. There is a place to record the sound, right? So click on the button, you can hit record, which we're going to demo that in just a sec. And then on top of that, we also have AI response, and then whatever transcription that's coming out of it, right? So let's make sure to share sound. So let's record. What is 1 plus 1? What is 1 plus 1? And then we can hit process voice, and then it will make that API call, and then it will play something back, right? So this is the response in terms of natural language. Now you can also play it.
1 plus 1 equals 2. That's one of the first math facts we all learn. And it's the foundation for all arithmetic that follows.
And there you go, right? So we have a speech-to-speech framework. We have voice going in and voice coming out. And then for fail-safe, you can also read the message if you want to, just to double check that what you're hearing is what you're reading. So thank you for watching, subscribe and like.